Project 2.2, the 5-volt voltmeter. This here is the finished 5-volt voltmeter circuit. I should preface this video by saying that this circuit does not currently work. So this video will be more in depth on the theory behind the circuit and some possible causes of why the circuit wouldn't work. So starting here with the finished circuit, there is 3 interactive elements along with power coming in at the back. So the circuit would be used to measure something here. And there first is a header here, a 4-position header with voltage common and ground on the outside pins, and then a V in positive and a V in negative on the 2 inside pins. Now this V in positive would be used to measure whatever positive side of an analog voltage, whatever is being read. And then the V in negative for a positive voltage could just be connected to ground. But in theory, it may be able to measure negative voltage. However, this circuit doesn't include that, just a side piece of information. There are 2 buttons here labeled start and reset. The start button ideally would transmit data from this chip, which we'll be going into detail more later in the video. And it'll bring data from bits onto the screen so that I can start registering the voltage and reading it. Then there's a reset button, which would reset the count back to 0 and reset all the bits, which again will be explained a little bit more. Other than that, those are the interactive elements. As you can see, the finished circuit features a through-hole fully soldered PCB, front side and back side, as well as a custom 3D printed case. These here are brass inserts, and they allowed the case to be connected to the PCB with little nylon screws. The case also features a smoothed out design with rounded corners and a rounded base so that it's more ergonomic to hold. Here is the prototype of the 5-volt voltmeter on its side here. So the power would come in here, and as you can see, the display's over here. The reset button is right next to the power, and the start button is over here. So this circuit primarily uses the ADC 0804. It is an analog to digital converter. So the ADC, instead of taking a digital signal and outputting it to analog, it takes an analog signal, which comes in on its 6th pin over here, and converts it to digital on these binary outputs here, with the least significant bit being here and the most significant here. So when this button is pressed, it sets the right low after being high, and when the interrupt goes low, this is being read with a PNP, it sets the read low to convert the data onto the bits, and this pulls the data from the internal registers onto the bits. Then these bits go to SR latches. Since the bits only pulse high, the SR latches are simply there just to hold the information. All the SR latches reset pins are connected to the reset button. So this reset button, along with resetting the count, which we'll get into a little bit later, also resets the latches. So it's a general reset in a sense for the whole circuit. Then from these latches, there's a detour with some diodes to a 555. Now this 555 counter is being connected to 2 different counting circuits. One of 4510s, as you can see in this kind of mess of wires, and then another up here with these 4510s. So the count here is being driven by the bits of the SR latches, so that when the bits are high, the count will go high. This would essentially make the count keep counting up and up and up, and the count would never stop. So to stop that, the logic of the circuit is being controlled by AND gates. As you can see, the majority of these 2 breadboards are AND gates, apart from the ADC and 2 4510s here. These AND gates run the logic, as I said, and essentially when the bit reaches the desired count for its value, so for example, With this circuit, it measures 5 volts, so the least significant bit, which is 1/255th of the voltage, is about 0.1953 volts. So when it reaches 1953, then it would set the latch representative of that bit low. And this is done with transistors. Of course, the AND gates send out a high signal, so the transistors are simply being used to flip that, with the base pin being connected to the logic of the and then the collector being connected to ground, and the emitter going to the SR latch. So it sets the SR latch low, and in theory, this would make it so that whenever the bit reaches the desired count, it would set that subsequent bit's SR latch low, and then when all the latches are low at the 555, it would stop counting, and it would reach the desired count for voltage. However, that doesn't happen, and there are a few possible reasons why. One, it's possible that when the bits count out a low, that the high and the low caused by different bits is causing a short. This was attempted to be mitigated with resistors here between all the bits, so that they couldn't have a straight path to each other, and rather would be blocked by resistors to avoid a short. However, that's still possible in this case. Another possibility for some issues arise in just the sheer number of connections. This circuit features around 700 connections, probably over that. And of course, there's a possibility that a single wire or something of that like is out of place, and that could cause the circuit to malfunction. As well, with the finished version, there are 702 connections, so it's very possible that any of those connections are just slightly bridged or possibly out of place. However, the theory behind the circuit should hold true. Anyway, that has been the 5-volt voltmeter circuit. Thank you for watching. Have a great day.